if I can get through this in the amount of time we have available. All right, so I'm going to share screen, share the whole thing. Okay, and I'm hoping, Kristen, that we can have something that says, if you want to know about X, here's the recording, go to minute something or other.
Yeah,
there's going to be a lot of
that.
All right, okay,
Yep.
So what is UHDAS? A very short introduction. Using UHDAS at sea, this is based on what people requested, and so this is just what I'm going to do, and then hopefully I can get through all of this by about quarter till, and then we can, I'll look at the questions. I'll take the questions that were over in the questionnaire. So, and then after that, we'll open it up to the floor. All right, so what is UHDAS? A shipboard ADCP pings in the water and measures the Doppler shift of the water going past those beams. And if you use calculations to turn the beams into horizontal and vertical, and then include heading to orient everything to north and include position, you can get out at the other end the ocean currents relative to Earth in a profile below the ship. Those profiles are very noisy, and so we edit them at that single ping stage and make 2, 3 or 5 minute averages, 2 or 5 minute averages, depending on the frequency of the pinging and the instrument. So that's what ends up on the website for people to see, and at sea. And those are the data sets that people use afterwards to compare to satellites or make look for ocean current signals. And so we try to make the data as functional and usable as possible real time. It's used for operations and like dynamic sampling regimes. And each one of the computers on the ships sends us an email every day. And we have 40 ships. And so we get somewhere between 10 in the January and 40 emails every day with all kinds of stuff going on. And I will show you here. This is the publicly accessible monitoring page. Here's all the UNOL ships that we have. Here's all the NOAA ships that we have. Here's all the other ships that we have. And for any one of these, you could click on figs, and you can see what the daily figures look like coming in that we look at every day. And we go through these pictures, and then there's also an email that comes in. We are aided by a ticketing system, which is, let's go there, ticketing system. So we actually have a system that keeps track of all these ships and the problems that are still pending, et cetera, et cetera, et cetera. But that's supposed to be the short introduction. So back over here, using UHDAS at sea, a live demo. So what I'm going to do is, this is an import cruise, so it's not going to be very exciting. I'll show you 2 real websites that I snitched from the Thompson and the Langseth yesterday with permission. So we'll see from those websites what the people at sea are looking at. But right now, I'm going to take you through the how to run UHDAS at sea. And we don't want to start from scratch because then you have to wait a half an hour for the plots to populate. So let me log into the Walton Smith. No, don't do that to me. There, it's thinking. That doesn't mean it's probably going to work. Oh, come on. Sorry. Huh. I knew I should have set this up. Come on. Oh, don't tell me that. This is my problem. Yeah, I've got that, Drew. Thank you. I'm not sure what's going on. Yeah, I don't know. Oh, one Walton Smith. Let me take this over here. Oh, I bet I know. I'm going to stop sharing for just 1 second. I'm going to bet that over here, I'm on another computer. All right, I was troubleshooting another ship right before this started, so I've still got some fossils sitting around. Let's get rid of that one. It means that the port for desktop share is already open. All right, let's try this again. Cancel. Yeah, I know I'm not sharing yet. This is called the demonstration effect. I don't know if you've ever seen this before.
Yep, it always works perfectly when you practice it, and then when you present it,
Yeah, well, there we go. All right, let me go back to Zoom and share screen. Share the whole shooting match. Okay, all right, so this, let me move that out of the way. This thing right here, this is the Walton Smith desktop. So, and let me get my agenda up and put it over here so I can look at it. Okay, so what we have is an active cruise. You can tell, so active cruise means there's a directory for things to be written to. Even more than that, it's actually logging data. So over here on this UHDAS GUI, you can see the green bars. There are a couple things we want to see about that. One is that they are green, and another one is that they're green, the text is moving, and the text contains the stuff that we want. So oopsie, this is where our latency is. So I'm going to highlight a new best practice, which I'll show you I'll show you in a second, but at the end of this, I'll show you. But the bottom line is, for the good of the scientists, we want to have a web page up with the pictures. For the good of the operations, we might want to have a speed log up or a surface vector, which shows what the ship is, where the ship is. Oh, come on, pop. That's the latency that's going to be problematic. Not that one. That one. Come on. Move, mousy. Move, mousy. Down. There we go. Okay. You might want to have the figures of the ocean velocities. You might want to have the speed log. You might want to have, oh, come on, pop up. The bridge plot, which is the one that's right here. You can take these and put them in separate places, but you always want to have the green bars visible. So if you leave the GUI up and it's too small, then all you have is, if you leave it up in that mode, there are green boxes over on the right, but if you don't have enough pixels, it doesn't scale right and you can't see them. So there is green up here, so you can tell if it actually fails, but you can't tell if an internal message goes away. So having your entire desktop show just the GUI on the front page is not good. What you want to have is the monitor page, which is where it lands when it's done starting, and stick that over on the right, and then you can put other stuff up on top of it. All right, so back to figures with frames. We'll talk about the website soon when it's better, when we have better pictures, but there it is, there's the website. Okay, so here we are, we're in the middle of a cruise and we need to operate on the GUI here. So we are going to change settings. To do that, you go to the control tab and you hit, click the control tab. You stop recording. So do you want to stop data acquisition? Yes, I do. So it flips over and has a little wake up message for each of the sonars. And a wake up message means that you get this little text down at the bottom that says, hi, I'm a something or other. And then it flips back over to this tab. So let's suppose we emailed you, or you realized you're in really deep water and or you're, put it a different way, you're coming in on the shelf and you are concerned about your calibration. Your scientist is concerned about that. And so you say, okay, I want bottom track on. And if you have bottom track on, you have to turn one of these guys off. So we'll turn off broadband mode. So we've just made some changes. And then you can say start recording again. It'll go over here and it'll flip through and have a dialogue with each of the instruments, send the commands to the instrument, and then ask, what commands do you have? All that stuff gets written down to text files so you can search them later. After it's done sending its dialogue to all of the instruments, it flips over into the monitor tab, and so you can scoot that off to the side and keep going with all your pictures. It takes a while. When you stop logging and start logging, it should come up and say not logging. There you go, no figure at this time. You have to wait 5 minutes for the first pictures to fill in, and then you have to wait, since we already have some data, it'll take 5-10 minutes before the rest of them all fill in. When you start from scratch, it's more like a half an hour. If you're starting a cruise from scratch, go get coffee. Make sure you've got green bars and then get coffee and come back. Okay, so now we've sailed along for 6 hours and we've just come into port. We've got our little bit of bottom tracking. It's time to end the cruise. So we go back over to control and we say stop recording. Yes. Blink, blink, wake up. The wake up is pretty fast. It just sends a break to the instrument. Okay, and then now we want to end the cruise. End the cruise, yes. Okay, so with newer installations, which I think means everything except NOAA at this point, we have, there's bookkeeping that takes place behind the scenes. And so at this point now, the last thing it does when you say stop cruise is it goes into this log page and shows you that it's doing something and it's thinking. And that usually takes 10 to 15 seconds. So it's cleaning stuff up, moving files around, gathering metadata and that kind of thing. And then it goes back over to here. So at this point, I see that the chat exists, but I don't see.
Oh,
what
yep, that's just from me. I'm just letting people know that they can use the chat if they have any questions.
Okay. So at this point, we've got two choices. We can either start a cruise or we can kill the GUI. So if we say kill or close the GUI, that's what we mean. Shut the window down. If we say launch the GUI, that means go up here to this little icon that's supposed to be a ship with some ocean vectors under it. Click that once and the GUI will come up. And you can proceed with, you could go back and connect to the old cruise. If you had like a medical emergency and an EEZ or something, you might want to stop logging in the cruise, or maybe you got excited and you stopped logging and ended the cruise. You could, when you start a cruise, either you could type the previous one or type a new one. Usually we want to see date first, month, year, month, day, because then it'll all sort properly. You don't want to name a cruise October 9, because that's at least not for a real cruise. So the way you would start a cruise is test 2024 08. Oops, 08. What are we at now? 21. That's our test. Okay. It's just making a directory and filling it up with subdirectories that are necessary for the processing. So at this point, you would change your settings. So let's say that we want bottom track on again and broadband off for the first 6 hours or something. Start recording, and it sends the commands to the instrument, and it takes a while for these commands to get sent because we've built in gaps or delays. We've built in small delays so that if you have a dumb instrument, like a dumb old one, or your baud rate is really slow or something, that it doesn't get all confused. All right, notice how slowly the broadband or the OS75 pings are coming in. That's because we've got two pings, we got narrowband and bottom track, and those each go out into the water, get sucked up, and then they come back. And so the timing on these is all of those pings get grouped together. Let's say that there's been a problem and you're troubleshooting and you now need to send a command to the instrument. So we're going to stop recording. There's two ways to do this. And I want to point out a couple of things. So one of those is, we'll wait till the wake up messages are there. Okay, so let's go back to terminal. So note that the GUI is up, and behind the scenes, I will show you, this is not something you ever need to deal with, but I'll show you. There are these things called lock files. And at this stage, TTY USB 2 is the one on the left, and TTY USB 3 is the one on the right. And the reason these lock files are here is because it says is connected. So is connected means that we can have a two-way conversation with this. And so if we need it, and this is the communication baud rate, we typically get the data at a different baud rate, but we're communicating at 9600. So let's suppose that we need it. See this command up here, PS0? That's benign, I can type that. So what you do is you make sure it's connected and go down here to the bottom and say PS question mark, or whatever somebody told you to do. PS says show system parameters. If you say PS0, you get the transducer parameters. So PS0, for instance. Typically what they would say is, I think PT200 runs a bunch of commands that are meant to show you the health of the instrument. And I would have to say that this is not anywhere near as good as a Kongsberg multi-beam BIST test. It's just not. It's not that it lies. It's just that it's not as useful as would be nice. But we ran it. I believe the same thing can happen over here on the Workhorse 300. No, that's the Workhorse 300. This is the OS 75 PT 200. So the content that comes out looks different because these instruments are different models. But anyway, that's how you send a command when the GUI is up. And so then you can go up here to file and you can say save previous, and that'll put it on the disk. And then you can say, you can figure out how to get it into an email, or you can say to us, okay, it's there. I named it for Jules 22 or something hopefully better than that. For Jules 2024 0821 OS 75. That would be better. So you can save the content. Now I'm going to go back over to start logging, and I want you to, so remember this says is connected. Is connected means we have a two-way communication. If I go back over here, come on, go. Okay, and I say start recording. When it does the Workhorse 300, watch it up at the top. I'll put my mouse on it, and over on, it'll take a minute because over on the right, it'll then have to do the OS 75. But what it's going to do, see it says is connected. It's going to send these commands out. Oh, actually, it probably isn't going to disconnect yet. Not connected. See where it says not connected? So if you look in here and it says not connected, don't freak out. The not connected means that the process that's doing two-way communication is now no longer doing two-way communication. It has handed the reins over to these processes, which are doing listening only. So when you say is connected, not connected, you have to have it connected to be able to talk to the instrument. But when it has green bars, it'll say not connected. So again, there's the not connected. All right, let's go back over to control. Stop recording. Yes.
And Jules, I have a couple of questions about naming of cruises when you're ready for those.
Oh, sure. 1 second. We're just about there. All right. And the cruise. Yes. Now we have to wait our 15. Okay, hit me.
Okay, I got two different questions. One of them is from Lynn Butler. She's asking, or she says, cruise ID that we use the cruise identifier such as EN 720, do you recommend that we change this to year, month, date? Thanks.
Nope, absolutely not. Absolutely not. There are probably 4 or 5 different standards people use. Your standard, which is ship letters and a voyage number, is used by the Hui ships, Endeavour, and Thompson. And that also means Rachel Carson. And another strategy is like the Kilomoana would be KM, 2 digits for the year and 2 digits for the sequential cruise number of the year. And the Sikuliak has a more complicated one, SKQ, I don't remember if it's 2 digits or 4 digits for the year. They have a sequential cruise number or a sequential, they put an S in for science or T for transit. Falcor is, again, sort of, Falcor, Investigator, they're all sort of similar in that they've got more complicated versions of the same thing. But in all of those cases, the ship letters are right up front, and there is something that's sequential about it that always sorts properly. So no, I definitely do not recommend that University of Washington or Hui or Rhode Island change their strategy.
Okay, great. And then another question from Robbie. He was asking, he said, I see that dashes are in the cruise names. That used to be forbidden about 20 years ago. Are they still forbidden? That's true. Okay.
Nope. Dashes are okay. Uppercase, you have to start with letters. Uppercase and lowercase are fine. In the middle, you can have underscore, dash, numbers, or letters. That's it. Basically, it needs to be an easy, valid Linux directory name. So nothing that we would have to put in quotes. Okay, the other thing I was going to do at the end here, remember we have TTY USB 2 and USB 3. If we look at those lock files now, they should be gone. They are gone. So we are now free. If you want to use the serial tool over here, tkterminal.py, you can do it from the command line or you can call it from the button. Let's do it from the button. Okay, so this is actually a standalone wrapper around the same little box that we saw in the monitor tab. So we can go to port, device, and we can pick TTY USB 2. Not connected. And we need, so it's 9600 baud because that was the default, but we can change the baud rate. Command, file, connect to port. Now it's connected. Now we can send a break, and now it will give us our answer. So when you're troubleshooting and you get it out of the box, this is the first thing you want to do. You want to find out what baud rate it's communicating at. Is it 422 or 232? You will go have a beer after you see this message, because this is a big deal. This means that you have communication with it. And the next thing to do would be either bucket test it or put it in the hull or whatever. But this is the first thing that you want to see. And then we can go down here and we can send these commands again, whatever they are. It is potentially advisable to do this within this TK terminal program, because the GUI, especially if you're messing around with baud rates, because the GUI specifically has one baud rate for communication and a different baud rate for data. If you're in the GUI, you cannot change the baud rate. So if you need to play with baud rates, you have to do it from within this tool. I will go up here and I will say disconnect. And let's get out of, so now we're done. Let's get out of this one. Let me go back over to my agenda. We did that. Okay, let's look at the best practice. No, let's look at the live websites. Okay, so I have 2. So I'm just gonna, oh, right. So there is one thing here. I can show you, this is, so this one thing on the right, the speed log over here, you should be able to get that by clicking this speed log button, which I can't do on the ones that I took away from Langseth and Thompson yesterday, but all the rest of the figures are there. So let's get rid of the desktop. We're done with Walton Smith. Thank you, Walton Smith. Thanks, Don. Chip. Okay, so let's get out of here and let's go to this one. So this is the Langseth, which I took from the ship yesterday. So it's an actual static website. It's got links. Okay. So figures live, that takes us to, come on, do it. Why is it not opening that? All right, hang on. There we go. That's what they saw on the ship yesterday. So I'll come back and explain these things in a second. That's what we call figures live. Figures explanation. Sonia Berger wanted to know, come on, why are you not opening up these pages? Oh, I know why that one's not opening. Because it's pointing to the website. So let's go to the CODIS documentation website. And let's look at UHDAS operations. So in the operations, couple things. There's a UHDAS CODIS overview. This one here, website overview. The reason it can't find it is because the link to this location on the ship is not working on my computer. But this is a breakdown. Again, this is in the newer installations, but it's probably not in the older ones. I don't remember when I rolled this out. After March of 21, whenever I got around to it, Drew and I were on the Thompson, and Sonia asked, before she left the Thompson for Woods Hole, she asked, is there some place to find an explanation? So that's what this is. And that's basically, this is what I'm going to do right now, is talk about these things, pointing to the actual website. But you can go to this, where to go, what UHDAS website overview. So if you want to know about UHDAS and CODIS, look at the overview, the website overview. Here's the best practices page, which we'll talk about just a little bit soon. And then UHDAS GUI tour is a longer version of a longer PDF part of what I just showed you. ADCP instructions is really short. It says click the button, start the cruise, start logging. And one of the best practices is once it's going, don't touch it. And another best practice is don't touch anything. Okay, so let's go back to here and figures live. Okay, so figures live with frames. So the one on the top is these are the 5-minute plots. This is, oh, that's very funny. This has to be, I should put the ship on here. This is the Langseth. It has to be the Langseth because they only have a workhorse or a OS 75. The 5-minute plots are, single ping has already been edited. And so for instance, the all these streaks that you see over here, this is acoustic interference from other instruments, but we remove that. The instrument removes some of it and we remove more of it. And that's why part of why the percent good, well, we're not removing very much here, but in some cases, if there's a lot of interference, you can see the green percent good, which is ours, and the black percent good, which would have been the original. We have trimmed away a few percent and made a huge difference in what the averages look like. So the middle plot is the ocean velocity going east and going north relative to the ground. 0.2 is 0.2 meters per second. That's 20 centimeters a second. So it's mostly going red, east, mostly going east. So it's going east mostly, and then the north-south component is pretty static, pretty zero. So if we go back over here and look at this one, you can see the first panel is the east-west velocity, second panel is north-south, third panel is the averaged signal return. And so from this, we can see, whoops, that's not what I wanted. I wanted it to get bigger. Okay, this is the bugs. The bugs come up, the bugs are near the surface at night so that because they're safe, it's dark. And then the bugs go down because when the sun comes out, they can be seen by predators. And so there's a very light, persistent scattering layer here at about 400 meters. These bugs are going down to somewhere around that level, and then they're coming back up again. The fourth panel is percent good. And we can see the ship speed, which is green. So they're going and they're slowing and they're going and they're slowing, and they do that until 40% of the way through. And then they start going, looks like they're doing a pattern. They've got one direction, they turn, they've got another direction. They go in a complete circle and they go the same direction, but they're going slowly. These guys are putting in ocean bottom seismometers on this cruise. And so they're doing a lot of surveying. During this period right here, when they were going around in the circle, they must have a little bit of a sea state, because the percent good means percentage of these pings that made it into the average. And so usually if you see bad percent good or decreased percent good from top to bottom, you can expect the velocities might look a little bit worse, because the instrument has got a lot of bubbles. I don't actually see any effect at all. And when you're looking at these data, one of the things you want to see is there any impact of the ship's motion on the ocean velocities? The answer to that is basically no. Whether they're turning or going straight or going faster or slower, you can't see any stripes in the velocities. That means that this is a well-calibrated instrument. So we've got those. Oh, here's the other thing. You can see in the percent good that there's a hole right here. Broadband mode doesn't hear anything reflected from that hole, because the bugs are below it or above it. That's one of the reasons I like narrowband mode so much more, is you get these holes in the middle of the data, because the broadband mode it's not as beefy. Okay, we got the 5-minute plot. We've got the panel plot, and then the third plot is a vector plot, and it's a near surface vector, not at the surface, in case there's some biases near the top bin or two. Green is go, red is stop. So it looks to me like they were doing, if we could zoom in on it here, they were doing some sort of survey through the whole beginning of it, and then they had a constant speed as they went southwest, did a circle, and came back up this direction. So there's vector plots for both. And then the bottom plots, essentially, if we have a plot that works, we never remove it. These plots are heavily averaged as a function of either longitude or latitude. Use your brain when you look at these plots. If you're going from south to north, then the plot that's as a function of latitude will work, and the plot that's a function of longitude won't. You can see a little bit of that down here. They're mostly going north and south, but they did repeat themselves. And so these stripes here are because they crossed over the same water, and probably the tide was different. And so they've got two sets of numbers that are getting jumbled together here. So sometimes these bottom panels are useful, but usually not. Over on the left, we have all of the heading devices compared to one of them, the one that we consider to be reliable. So in this case, we have a gyro and CPath. There's always an offset between these things. In the case of the Langseth, there's enough of an offset that the CPath is throwing error messages, because it says, oh my God, there's two different, so this is horrible. There is an artifact here that every 2 hours when our files roll over, we miss one ping, and so there's always a red stripe there. But that's the POSMV versus the, CPath versus the gyro. Here's the POSMV versus the gyro. And down here, we've got the bridge plot. So this is the orientation of the ship. This is done every 5 minutes. So this is the orientation of the ship. And you remember earlier on, I said that the velocities were mostly east. Well, there it is. It's mostly east. Happens to be near the surface. It's mostly east. Let's go down and look at this one, vector profile. So keep that one in mind. And let's look over here. Okay, this plot on the right is the same plot. Here's the velocities going mostly east. That blue, mostly east, is this blue right here. So the legend says 47 to 63 meters, so basically around 50 meters, 0 through 200 meters, 50 meters. That's 50 meters, and that's where this arrow starts. That arrow right there starts at 50 meters. And then it looks like every 75 meters or so, I have another vector. So all these vectors are pointing to the east, and they're a little bit stronger near 400 meters and much weaker at the bottom. And if we go back over and look at this one, we can see at the end, the velocities are all to the east, top to bottom. There is a little stronger point here around 400 meters. And the velocities north to south are not strong at all. They just wiggle a little bit. So that's how you, once you get used to this figure, the people who are doing ROV operations and over the side work, they really love this one because it's a top down view, not top down, it's from top to bottom view of all the vectors, but they're all drone pictures. So it's like you take a deck of cards and you take every bridge plot from each of these different sets of depths, and then you lay them all out on a vertical grid to the depth where they come from.
We had a question on these from Chris Ramsos. He wanted to see if there was a Z on these.
If there's a what?
If there's a Z.
A Z? Yeah, there's a Z on this one. That's the Z on the left. I assume that's what he's asking about is depth.
I think so.
Sorry, Jules. I just did. I guess I don't look at these plots a lot, so are you measuring vertical velocity?
No, absolutely not. Most of what vertical velocity is on a shipboard ADCP is the ship pumping up and down. Or when you're going forward, you might have a little bit of a pitch bias. So when you go forward, you're going to be creating an artificial vertical velocity because of that. There are locations and instances where oceanographic vertical velocity is discernible and it makes sense coming from an ADCP, but usually not, especially not in the open ocean where vertical velocities are on the order of centimeters per day. And so we absolutely can't measure centimeters per day.
Okay, another one we had, it says, in the vector plot, is it true that the color doesn't matter on the vector arrow, but the length does?
That is correct. The color is merely an indicator of red being warmer water, probably near the surface, and probably colder further down. It's just so that you can tell the arrows apart. The only thing that matters here is the length of the arrow, and the scale is down below, and the direction is a compass rose.
Okay, great. And then this one was from a while ago when we were turning on and off bottom tracking. It's the question was, is there a reason that we have to turn off one of the instruments before activating the bottom tracking?
You have to shut down logging completely. That was a design decision, and the reason is that a lot of effort went into making sure that all the files start and stop at the same time. And so we do not have one instrument still logging while the other one is being messed with.
Okay. Okay.
Go ahead.
Oh, and I was gonna say, didn't you also turn off, was it the broadband for one of the instruments as well?
That was semi-arbitrary. That's just
Okay.
because I like narrowband better, but if you're in shallow water, probably broadband will work fine, and it does have higher resolution.
Okay.
Okay, back to here.
Thank you.
I would say, so these ones, the bridge plot is an operational plot that people really like. These other ones down here, I think are really not very useful, so I'm not going to show you. And so the speed log, I pointed to the speed log display on the other one. Also, we can output the speed log via either serial or UDP. And so if your ship wants a UDP speed log output so you can log it or something, let us know if you don't have it. Okay, this one is these ones are diagnostics. Here's a diagnostic plot. So these are beam velocities. So in the 5-minute plot, we had the 2-minute plot of the Workhorse 300. We had the last 2 minutes worth of stuff over here, and there were some little stripes. Here is I think this is the last 4 hours. And the main point of this is not to talk story about the acoustic interference, but to look at the beams, the 4 beams, and they are all giving data. There is not one beam that's shallow to 100 meters and 3 more that are deep. This is where you look to find out whether you have a beam that's failing. You can see over here, we've got little turds, I guess. There's little bits of stuff in the data, and those are the bits that we would be removing by looking at the acoustic interference and taking out all this stuff and all that stuff. And once we do that, then all these bright speckles will go away and we're not averaging junk. The other thing you can tell is that beams 1 and 3 are pointing forward because they're redder. Beams 2 and 4 are pointing aft because they're bluer. They are roughly symmetric. So this is almost a 45-degree angle, and these colors are not saturated, so it's not going very fast. So that's if your range suddenly gets really low, this is a good plot to look at and find out whether you've lost a beam or not. We do get a 9 pings or 10 pings. We get 10 pings from each daily email. So we look at 10 pings a day to help make that determination. Last pictures, ocean velocity arrows. Well, I put it there, but it's not very useful, so don't bother. Temperature diagnostics. This one is important and interesting. Temperature from an ADCP is not a scientific measurement. There are multiple reasons why. Well, it's a thermistor. It's potted inside of the transducer, so it's not going to be very reactive to the outside water. Probably not very accurate, but look at the fuzz on this. This looks like a caterpillar. The temperature seems to be a canary in the coal mine about electrical noise of the instrument. So this fuzz is a lightweight level of some kind of electrical noise getting into the analog cable. It's not affecting the velocities, but if you have spikes that are like 20 or 30 degrees, then that means you do have an electrical noise problem, and you are probably going to see degradation of the velocities. The other thing is that if you get water in the transducer, these numbers will peg out at 92.4 Celsius or something like that. And that means that there's a connection that has been shorted. And that means your instrument has a week to 2 months left to live. Apparently, pinging on it under those conditions doesn't actually hurt anything, but you're probably gonna, you should get worried. And we have GGA time differences. Okay, so remember I said the CPath was different from the gyro by 3 degrees on this ship. Well, it turns out that every time they're pointing in, we can't see the heading here, but every time they're pointing in one particular direction, there's some kind of shadowing or something, and the CPath says, oh my God, oh my God, oh my God, I don't know where I am. I'm gonna have to guess. And it's actually not causing a problem. I did look, but very often if you see this free inertial flag in the POS-MV or CPath, it means that the position has drifted off baseline by, it could be 50 meters, 200 meters, and it'll come back when the free inertial flag goes away. It'll come back and it'll be good. But I don't know whether modern CPaths are doing this more than they used to do it, or whether we're only seeing it because we realized that we had a problem and we could add these little pink lines to show us when it was happening. So this could be a case of there have only ever been salamanders under rocks in the last year, or it could be the case of we only started turning over rocks in the last year. Now we know there's salamanders there. That's probably what's going on. So that's what this plot is for, is to look for problems with the timekeeping, with the GPSs. Okay, down here, I did the vector profile plot, and then there's this one, last few vectors. So this is by request from a scientist in Norway. We were putting a UHDAS on the Norwegian fisheries ships, and the guy who was spearheading us doing this was used to VMDAS, which is the commercial acquisition system, and VMDAS has a little vector plot like this. And he's like, I want my vector plot. Where's my vector plot? And since I was sailing for a week and a half, that's what he got. So if it's, it's got a shallow layer and a deep layer, and it is slightly smoothed, but basically these are the 5-minute averages, and the origin is where we are. So right at the moment, this is the last hour of data. The ship was going to the northeast. And so what he was looking for was a vector plot that would show him with quick turnaround when he got to the other side of the eddy, because he wanted, or the middle of the eddy. So he wanted to be able to throw a float in the middle of the eddy. And so that's what he was looking for this one. This one updates every 5 minutes. Oops. The GGA one doesn't, the GGA one and the temperature ones are more like on a half hour, because they're they're not like rapid response troubleshooting. The rest of these are all, and these ones up here might be, I don't remember how often they go off, but most of these plots update every 5 minutes. So it's just a little chunk and it moves over. Okay, we are almost done with the stuff that was on my list, except for best practices. I just want to go here and show you. Oh, I didn't get it in there yet. Hang on a second. I think I have it here. Do I have it in that one? Okay. When I log into a ship desktop and there's a cruise active, and this is what I see, I'm very sad. Because this means that if all of the, it means the only monitoring you can do is to look at the timestamp at the bottom and compare it to a UTC clock. And that's a big ask. You want something that's really in your face to show you if there's a problem. This is an operational plot, but it makes a lot of assumptions that everything is going to be fine and it's going to continue to work. This one is slightly better in the sense the difference between these two is the size of the window. This one just happens to be scaling so that the little bars at the top are not showing. If you bring it down, at least in this picture, you've got green up here. Green means something is coming in with a good checksum, but it would not tell you that your POSMV GGA message is all commas or something like that. It wouldn't tell you that. This is what we want to see. We want to see science figures so people know that the instruments are there, the website is there, it's doing stuff. We want to see the green bars on the right ticking through so that you can see the letters moving. And then the bridge plot or any other diagnostic or operational plots, whatever plots you want. But I really, really consider it best practice to at least have the green bars up. And then we're doing this for science. You want to have some pictures up too. So that's it for the fire hose. And there's all these questions that people had. Should I just run through them really quick and then open the floor?
Yeah, I think that sounds good. So thank you everyone who responded to our questionnaire. I think we had like 24 responses at the end of it. So yeah, Jules, take it away.
All right. Some of the figures can be tricky to interpret at a glance. That's true. There's a lot of information there, and there's a lot of different vectors and velocities and axes and stuff like that. But hopefully the combination of having seen it here and the location on the website, not that one, operations, go back, website overview. Take a look at this, and I mean, if the more you can understand, the better, because then you can explain it. But worst case scenario, you can point your scientists to this page. If it's not on your ship yet, it's out there in the universe. Yeah, okay. Not having built-in diagnostic commands for bucket tests or for returned or new ADCPs, not under my control. I feel your pain. I'm really sorry. There's nothing I can do about that. All I can do is provide TK terminal or that little bar you can type commands into and the commands that they gave us. That's all there is. I'd be curious to see the way the information goes from the ADCP data to the pretty vector graphics. If whoever that is, if you want to get together for a different Zoom, I would be delighted to answer any questions you have. But how it goes there, can I do that quickly? Yeah, I can do that really quickly. Let's go to oh, that's because 01 doesn't exist. Let's try 3. Okay, here I am on the Kilomoana because I closed the cruise on the other one. Kilomoana. In the home directory, an active cruise means that there's a symbolic link that says cruise that points to the actual location of the data. So if we go to that location of the data, we are collecting data from a Furuno, a gyro, and a POSNV, and 2 ADCPs. The Furuno, the POSNV, and the gyro data are coming in ASCII here. It's a timestamped version of exactly what the enemy message is. And then these are translated to be easily dealt with quickly, large numbers of files. We write these with the tool. So it has the timestamps, and then, for instance, a GGA message would have decimal longitude. So you have time, decimal longitude, and then whatever other values were in there. And so we use these, we grid them onto the ADCP timestamps. So this is the gridded version of all of those ancillary feeds for the OS38 and the gridded version for the Workhorse 300. And then the single ping editing and averaging happens, and it all goes into these databases, and then we make a bunch of plots. So if you want more information, email me. There were 3 in here that basically said, okay, getting UHDAS and my organization to be friends, that suggests that you don't have it. A Spanish question, which translates to how do I get UHDAS on my ship? Is it free? Do you need an expert team to install it on board? All of those answers are basically, the answer to all of those is basically the same. It is open source software. If the Chinese wanted to reverse engineer the configuration files and figure out what all the packages were, I'm not going to stop anybody. You can take it. It'll all run. There isn't anything. There isn't very much that's not provided by our software or Linux libraries. But we don't have the way to make the configuration files is not public, and I'm not going to help. It's enough work that we're paid to do to try to keep all these things running than to be able to help somebody pro bono get this stuff on their ship. However, shipboard ADCP data coming from RDI instruments is collected by either UHDAS, which is then turnkey setup for our stuff, or VMDAS, which we've put a fair amount of effort into making our CODIS processing work with VMDAS data. So if you want to have access to all the tools that we have for single ping editing and averaging and viewing, you can use the CODIS processing. It's free. We do support that, and we do help people with that. If you don't know what to do about that, you can go to the website, go to the front page, CODIS installation. So UHDAS is the acquisition system. It wraps around CODIS. CODIS does the processing. You can put CODIS on your computer. If it's a Windows computer, somebody has done it for Windows subsystem Linux thingy, but I don't recommend that. If you're on, we have a virtual machine that's already configured that we recommend. And if you're on a Mac or a Linux machine, we would recommend using a Miniconda environment. Okay. Thank you for your nice words. Installing the Workhorse 300 was a daunting task. How that hard? Okay, that's actually, I think, very similar to the graphics question. I guess I would say if there is, you can write Kristen with this. If there is a further interest for a more detailed discussion about internal data flow, internal UHDAS data flow, and graphics and graphics libraries and stuff like that, get with Kristen and we can find out. She can be the clearinghouse, and we can set up another Zoom for whoever wants those details. Interpreting the figures. So there is that entry in the website. Not knowing how to operate a Linux computer. Okay, I get that. I have a couple of responses. One of them is, that's how we want it. We want you to be scared. We don't want you to go in there and start messing with stuff. So no, I'm sort of kidding. You know, if we ask you to do something as our remote hands, obviously it's better if you know what you're doing. If you think it would be useful for us to put a very short entry into the documentation that's got the basic Linux commands that you might need, you know, just to like open up a notepad or change directories or copy something, we could add a page with the basic stuff that you would need to do. But I went out to a desktop this morning to look at a request, and I was absolutely appalled to see a program open in an editor that nobody should have any business touching. So this is, you know, if you mess with anything, it's a finely tuned machine. All those statements about no problems, it works great, that's because they don't touch anything. Any other questions? Let's see, vertical currents. Oh, Sentinel V, that's right. The Sentinel V has a vertical beam. We are recording it, but we're not using it. CODIS was never set up to deal with that vertical beam. And I think the Sentinel V's vertical beam is probably most useful if it's on a mooring, because then you can look at wave height. But when you're on a ship in the middle of the ocean, the vertical beam is not going to be as useful, and it won't help you get W. Let's see. How can onboard techs use ADCP to help inform other deployments and recoveries? Well, that would be to use the currents and figure out. So first you want to deal with the waves. What are the waves doing when you set the ship up for a station? And then what's the wind doing? Where is it gonna, I'm most familiar with CTDs, but I know, I mean, anything over the side, you have to pay attention to how the how the ship is going to interact with the way you're putting something over the side. You don't want the ship to drift into your cable. But then the third thing is, are there any really strong currents that you want to know about? Like if you're trying to deploy something on the equator, you can have really strong currents that are zooping along at 100 meters or 200 meters depth, and it can totally take your CTD off to the side, and you might have a lot of line out and not be able to get it to fall. So as much depth as you have in the ADCPs, you can help. The currents might be able to help you. Uncommunicative gliders or drifters. I don't know that there's anything the ADCPs can do to help with that. How can we use ADCP data to predict elevator areas? I'm going to assume an elevator area is a region of very fast vertical upwelling. That would be one of those cases where if you have strong tides against strong topography and you slowly steam back and forth over that area, you might be able to see upwelling on the other side of a ridge or something. Oh, here's another +1 for Linux commands. Yeah, let Kristen know about that too. And if there's something we can add to the documentation, we're more than happy to do that. All right, I'm gonna stop sharing because I see Chris has his hand up. You're first. Well, actually, no, wait, there's a whole bunch in the chat. Let's go check this out.
Yeah, sorry, Chris, you'll have to wait. And for the people that have to drop off, thanks for joining. But for the people, Jules, do you have a couple more minutes to answer questions? Okay.
Yeah, absolutely.
Okay, great. Well, thank you everyone for joining. If you do have a couple more minutes, stick around and we'll answer some more questions. So
yes, I see the next one up is web for ships using Open VDM for cruise management. Recommend using their own cruise ID for the first cruise and _ ABCD for the following ones. Some people use ABCD, some people use part 1, part 2, part 3. Whatever it is, it should sort properly. So the trick there is that if there's a problem with an input, for instance, the CPath is what we're using for accurate heading, and the CPath goes belly up, we have to we want to switch to another heading device, accurate heading device. That is a completely different set of processing, and that involves changing metadata and changing inputs. And so you have to stop logging, end the cruise, kill the GUI. We would make the change to shift the parameters around. So we have to do this in conjunction with whoever's on the ship, and then start up the GUI again so that it reads those new values, start the cruise, and that's where you want to put part 2 or B or something like that, and start recording. And then, so another time when that might happen is if there was a UPS failure and the computer went down hard, then the last bits written into those files are often all nulls. And so the processing can never recover from that. So there are situations where you have to have we would call it another cruise. It's really another cruise segment. So anyway, hope that helps.
Yeah, Jules, that was really just for as we were in that part of the discussion for any of the ships out here using Open VDM. I just kind of wanted to clarify what's been working well thus far so that doesn't break their data management. Because we typically set up the data management for working with UHDAS so that it basically looks for a directory with the current cruise ID and any suffix.
A wild card, right? And I'm going to riff on that. Hang on a second. Okay, so not the best example, but let me share screen here for a second. This is just an example, but it'll speak to exactly what you're saying. Okay, so this is one of the best practices things. Inside of any one of these cruises are subdirectories. These subdirectories. Do not archive those subdirectories. Archive the cruise name. Even though it seems redundant to have KM2401, CTD, ADCP, XBT, something or other, and then in ADCP it says KM2401. There's a reason for that, and the reason is here we have KM2401, 2401A lowercase, 2401A uppercase, and then 2401A, and that's going to be one that doesn't have any ADCP data in it. It's just ancillary data. All of these are what Web would be archiving, or what you should be archiving. So it would be KM2401 star. And
Yes.
those should all go into the ADCP cruise distro.
Correct. Yep. Just
Yep.
wanted to
Yep,
clarify
excellent.
on that as we were talking about adding dates and stuff like that.
Yep. Excellent point. Let's see. Here is a link to the operation. Okay. Is there a V on these? A Z, not a V. That was the vertical one from Chris. No, there is we call it W. There is a W, but it's generally not useful. Yes, the color doesn't matter. Oh, do I see that? Okay, this is from Web, the bad practice. Do you see that bad practice? You're talking about the bars? Because the
No,
ship
sorry.
uses
For the bad practice, I'm referring to the bridge display. Like typically you'll walk in and you'll just see the bridge display and nothing else. I've actually seen that on ships because the ship uses a ship-wide KVM system and the bridge has requested to see that display. The only thing that I can suggest is that if there was a possibility to have a UHDAS display that included all of that other information that the techs need to be monitoring, but also the bridge display. So that way on the ships running a centralized KVM, essentially they can set it all up so that everybody is happy.
Okay, well, my suggestion on that would be to take that. So basically you're talking about a video distribution of the console, in which case leave the green bars up and use the website, use a web browser to bring up that picture that you want. Don't get the picture from inside of the GUI because it steals everything else. So leave the GUI.
Does that website auto refresh?
Yes.
Okay.
Yep. I think for every picture on there, whatever the timer is to create the picture, the refresh is about 10 or 15% of that. So I just
wanted to raise that because I have actually seen that exact behavior on ships, and it's been because the bridge really wants to see that diagram for deployments.
I get it. So there's another two thoughts. One is that if they have access to the network that the UHDAS machine is on, they can bring up any plot they want in a browser. And I think what you're probably indicating is that there's not that opportunity for them.
Correct. They're just jacked into some central KVM. So they basically, they need to look at whatever the techs look at, or vice versa.
Well, and that's the other point. It is all available on that. It is all available on that website. And so they can have, the techs can have any computer at all with a browser up with all the figures. I don't mind that. I don't mind having the desktop be simple, but the desktop is the only place where you can monitor the green bars right now. So you've got to have them up there. So you get the green bars up, put them over in the corner, bring up a browser, bring up the one picture that you want, whether it's the bridge plot or the depth dependent bridge plot. Then there's just a little bit of green in the corner. They can probably get over that. And then you have all the rest of the pictures somewhere else. Oh yeah, that's right. And Lynn does that. So on the James Cook and Discovery and Endeavor, they have two computers. They've got a primary and a spare. And on the primary, they have the green bars up because that's what you have to use. And then they hide the keyboard, and the keyboard that's sitting out is for the spare, and the spare is the one with the website. And so they've got two monitors, and one has the green bars and the other one has the website. Lance is making a comment that you all have to read. That's not a question for me. It's just a really good chunk of information. Maybe, Kristen, can you copy that and email it out? Just to the people who came to this? Okay. Look at that. Chris gave up and he put his hand down.
I think Zoom has an auto hand lowering.
Your hand is tired. I'm going to put it down.
Yep. It times out.
Well, Chris, if you have a question, anybody else who's got a question?
So Jules, I have two more. One is, and I did put it in chat. I worked with a vessel that did exactly what you alluded to, where they're using CODAS without UHDAS, and they're basically rolling their own. And in that particular setup, they were able to output the binned ensemble data to UDP. So that basically gives you the binned for the various depths and whatnot. We actually ended up on that particular boat. We actually ended up taking that. I wrote a custom OpenRV transform to parse that multi-line data structure, and then we build a Grafana, a web-based Grafana dashboard that basically gives that bridge display, but at any depth that we want. And then we can combine that with all other types of sensors around the boat to give basically one web page that provides the bridge or whoever's deploying the vehicle, basically one-stop shopping for all of that information. And so I'm wondering, maybe that's overkill getting the ensemble, but I'm wondering if there's a way to get the data that's being visualized by UHDAS in a UDP format so that ships that do have other visualization capabilities can basically grab the numerical data and build their own visualizations as opposed to using the rasterized image that is generated by a UHDAS.
Fabulous question, and not here, but
okay.
Offline, let's talk about what the format of that would look like.
I'll see you in New Hampshire.
That's a true statement. Okay, that's great.
The second question I had is with regards to the mailer, being able to look at the ships on the Hawaii website. Is there a way to disable that functionality temporarily? I'm specifically referring, okay, so there is a button on the UI that's like, hey, don't phone home.
Nope, there's not a button. You have to be dangerous. You have to go in and you have to comment out the cron.
Okay. That really kind of comes into play. Vessels with ROVs that are diving on areas of cultural heritage significance, so shipwrecks, obviously. And I've dealt with vessels where they have to turn that off because they're going through pirate waters. Either off of Singapore.
What we want is for somebody to email us and say, we had that on the Go Ship cruise on the Lang Seth that went out of Cape Verde and went south. When they got in EEZ, they had to turn all that. They had to turn it all off. Okay. It wasn't just EEZ; it was pirate waters. And so, that's how you do it. There's no button for it because it's not that common. But you have to go edit, cron tab, and comment out the emailer.
Is there a section in the documentation that outlines all the files that need to be touched to turn that on, turn it off?
Nope.
Okay.
Email us. Just talk to us first, and we'll tell you what needs to be done.
All right. Now I know to email. Thank you.
And that's usually the answer. If there's any kind of a question, contact us.
When in doubt, bug you. You got it.
Yeah. Oh, absolutely.
Well, I'm just going to throw the documentation in the can and just replace it with your email address. Thank you.
I know you will.
There was another question in the chat that I don't think we answered yet from Benjamin Bagwell. Says, can I access all the commands for UHDAS through something like a MAN page in the terminal?
All the commands for UHDAS. Can I get clarification on what you mean by that? There is only one command for UHDAS, and that is das.py, and there's a button for that. All the other stuff that we might do are not really called UHDAS commands. And no, there's not a man page. there's a bunch of stuff in the documentation about if you have this software on your computer, here are various tools you can run, but I'm not sure what you mean.
Benjamin, did
just-
you have anything? Oh, go ahead.
Oh, sorry, I just meant for like interacting with the with the instrument itself, like you were doing earlier.
Oh, well, there's the instrument dot, you mean like the commands that I was sending to the instrument?
Yeah, so
Is that
that's from like that's going to be in like the manufacturer's documentation then.
Yes, so all I was showing you was our conduit to do that. So if we were not involved, or if you didn't know and you wrote RDI and you said, ah! And they said, well, run these commands, get BBTalk and run these commands. So BBTalk is their Windows-based program, which provides communication just like this. And so BBTalk probably spins through baud rates to find the baud rate that works, and then you can type stuff into it. And the stuff that you type in is in their documentation.
Okay, thank you.
Does UHDAS have the ability to sync to an external trigger signal for pinging? Ocean surveyors have a plug in the back that you can put a coax into, and there is a command in the up in the front in the GUI called CX. I think C is communication and X is transmit. If you have CX0, that means the ADCP does not listen for a pulse. If you have CX1, that means 1, 2, or 1 or 3. 1 means it's only gonna. I am the ADCP. There's a 1 there. CX1. That means I am going to only ping at the beginning of the trigger pulse. And a CX3 something is I'm going to ping at the end of the trigger pulse. That number is followed by another number, a 1 or a 3, or maybe even a 0, and that indicates what signal I might put out. So for instance, and this is how the RDI would recommend it, that you have CX01, which means I ping whenever I please, and I send a pulse out to somebody else when I'm done. And I think there's also a timeout, so you can delay the time when that occurs. Yeah, triggering is a whole nother discussion. We understand that it has to be done sometimes, but we're just about to have some drama here. My husband is going to wake up the cat and carry him into the other room where a vet is visiting and is going to examine his teeth. So yeah, the thing about triggering is that it can either leave scars in the middle of the ADCP data or delay the time between pings, sometimes so drastically that yeah, it can just be totally egregious. So the one big thing I would say about triggering is if you have some other instrument whose science overtops the ADCP, and you'll just take what you get with the ADCP. If you have an ocean surveyor or something, for God's sake, only use one kind of ping. Do not use more than one kind of ping, because the triggering will delay the number it'll reduce the number of pings that exist, and every ping is important. So no bottom track, just one type of water track if you have to trigger it. And people do. If you have a Workhorse 300, the only way to trigger it is to not use the deck unit, but to use your own power supply. And I would talk to either Scripps or Sekuliak if you want to talk to somebody who's actually done that. Sekuliak does that all the time with their Workhorse 300. I believe that the Workhorse 300 Scripps has the ability to do that, but they don't very often.
All right,
What
well, I
else?
think that was the last question we had. Anyone else had burning questions? Feel free to ask now. Otherwise, I think we might go ahead and conclude today's meeting.
Oh, here's one out of the box solution to the I'm on the bridge and I want to display my own stuff. I believe that they're now doing that with a tablet. Lance can correct me, but there was at one point the captain or first mate got a netbook. Remember netbooks? Little itty bitty computers with like little itty bitty laptops with keyboards too small to type on, and Velcroed it to Velcroed it to the bridge up there and had it on Wi-Fi, so they could get it was completely disconnected from other bridge information, but they could use Wi-Fi to populate a website with the pictures they wanted. Do they have a tablet up there now doing that?
Yeah, we have a tablet that, so long as it's connected to Wi-Fi, it can access like all of the essentially we just bookmarked the underway data pages. And so we always have a tab up that has the night version of the bridge plot. And then
Yeah.
you can go in there and put as many tabs up as they want to see the vector plots if for some reason they want that, or
Right.
whatever else. We just have a tablet up there that's doing it over a browser.
Yeah, I didn't show you that, but at least two of
That's
these
almost
plots
like if that stops working, we get a call instantly.
there are at least two of the plots, the ones that I was imagining the bridge might want, which have a dark red background and even darker red access lines for night vision, night viewing.
Yeah, for the bridge, that's all they look at. Nobody looks at the white background.
Right.
So
Thank you, Jules, so much for your
we're
time.
always here. We're always here. You're always welcome to email us. If we can avoid answering the same separate question from 3 different people, it's better. Anything we can put into the documentation that we can point somebody to is better. It's always a process.
Yeah, when in doubt, I always used to just email you guys.
Yep.
And it was great too. If you didn't know the Linux command, you could be like, I forget what the command for this is. And you get an email back and they're like, oh yeah, of course, there you go.
Right.
All right, well, thank you so much again. And we will get this